Welcome demographic profiling of respondents, descriptive statistics, and their analysis in SPSS statistics. What is demographic profiling of respondent? Demographics are characteristics of a population characterized such as race, ethnicity, gender, age, education, profession, occupation, income level, and marital status are all typical example of demographics that are used in survey questionnaire. Demographic information allows a researcher to better understand certain background characteristics of an audience, whether it is their age, their race, their ethnicity, their income, work station, marital status, etc. By asking demographic questions in a survey, one can not only gather demographic information about the current and potential customer at scale, but also it helps to better understand the identity of a particular respondent of your study. So, following are the example of different demographic respondents. For example, we can segregate our respondent to whom we have collected in the questionnaire data. So on the basis of the age, for example, we can categorize the age with respect to the 17 or younger, 18 to 20, 20 to 29, 30 to 39, 40 to 49, and similarly. You can also uh, distinguish the respondent with respect to their race, like white, black, Asian, and others. Similarly, you can also distinguish with respect to gender, either the respondent is male and or the respondent is female otherwise. Marital status like married, widows, divorced, separated. Similarly, on the basis of education, we can segregate the respondent demographics. So education means like intermediate, matriculation, intermediate, bachelor, undergraduate, graduate, and PhD. Similarly, on the basis of their employment as well as on the basis of their income, like moreover, we can also distinguish the respondent with respect to their sec- sector or industry to whom they are working. For example, someone working in construction industry, information technology industry, telecom, education, services, or health industry. So basically, this is how demographic profiling works. It's just used for to segregate or to divide in different groups and to identify the relevant participants or relevant respondent on the basis of their demographics. So we can categorize the respondent demographic with respect to their age, race, with respect to their gender, with respect to their income, working experience, education, as well as with respect to the industry or sector where they are working. Another concept that is descriptive statistics of construct. After demographic profiling, preparation in an thesis or article, descriptive statistics are used to utilize in order to see the data is easily understandable. So descriptive statistics involve summarizing and organizing the data so that they can be easily understood. We can say that descriptive statistics helps and understand the features of a specific data set by giving short summaries about the sample and the measures of the data. So the most important descriptive types of descriptive statistics are mean, median, mode, range, skewness, standard deviation, skewness, and corpus. So basically, what does the mean do? Mean is basically considered the average point. For example, we are having a data set of 20 which has been derived from 2, 3, 4, 5, 6. So the mean will be 4. How we can come up with 4? We just add these different 5 values and divide with the number of values. So this is how the mean has been derived. Mod, we can say that mod is basically the most repetitive word in any data set. For example, we are having data set that is 2, 3, 3, 4, 5, 6. So 3 has come twice a time. It is more repetitive, so we can see that the value of the mod from the data set of 2, 3, 3, 4, 5, 6 is 3. Similarly, we are also having the median. Median is basically, you can see that uh, as its name implies, median reflects the middle value from the data set of the above referred example. 2, 3, 4, 5, 6 is 4 because 4 is the middle value of that particular data set. So we can perform these different type of descriptive statistics to our data in order to analyze or summarize the data. So we can also perform descriptive statistics in SPSS software. This is basically SPSS. SPSS stands for Statistical Packages for Social Sciences. SPSS is short for Statistical Packages for Social Sciences, and it's used by various kind of researchers for complex statistical data analysis. The SPSS software package was created for the management of statistical analysis of social sciences data. It was originally launched in 1968 by SPSS Incorporation, but laterly it was acquired by IBM in 2009, and officially its name was declared as IBM SPSS Statistics. So basically, IBM SPSS Statistics is used to analyze the data, which is very complex in nature. SPSS is used by market researchers, health researchers, survey companies, government entities, education researchers, marketing organizations, data miners, and many more for the processing and analyzing of their survey questionnaire data. We have a demonstration of SPSS software to perform demographic profiling and descriptive statistics of the construct. To have a look what is the main display of the SPSS software. This is how this is basically the window of SPSS software. So we are having two different panes like data view and variable view. So in variable view, we have defined our variables and the value of corresponding variable has been entered in data view. So first of all, we have divided filling the basic requirements of data view. First of all, we are having different columns like name, type, where, decimal, label, values, missing column, align, measures, and role. What these columns should do. So name column is used for naming or highlighting the name of the variable. Type reflects, you can say that type reflects which type of data that particular variable should contain. However, the name in that particular column has been written without space. No special character has been used for it. And the type is used to represent the data set. Moreover, width column is used for maximum number of characters to be allowed for each response. Decimal number, you can say that number of decimal places. Label is used for labeling your variable. Value is basically, you can say that, is used to enter the data, what type of data it should contain. Missing value usually does not use. Column is used for column width. Align is either left, right, or center measure. These are basically measurement scale, either nominal, either ordinal, or scale. So these are basically the basic columns. So how we can enter the data? Just click on your first variable like it is knowledge management KM without reference. Just enter. You can see that we are having these columns are typically filled automatically. So this is the type of either your variable numeric, comma, dot, scientific notation, data, dollar, string, and etc. Along with decimal after consider decimal or number of places after zero. Label just labeling your variable like it is knowledge management. Value is used to represent one represent from two represent for example three represent this value. So similarly we can add the values according to the question we have designed. So we see the meaning of 1, 2 and 3. Three have been common with automatically so immediately for example scale type variable. Here we have defined our first variable that is knowledge management. And just write down the values in 1, 2, 3 according to the survey question. So how we can enter different values. This is how we can enter the values in SPSS software. I am having an example. We have defined a variable like name, ID, name, gender, and age. ID represents 1 to 3, so we need numeric type of value, name represents string value, gender represents numeric value, age represents numeric value. We also label them and define the values, and accordingly our variable has been defined and we just enter the data into it. ID 1, 2, 3, 4, 5 is just, you can write down according to your requirement. So this is how we can write down the values and it according to the requirement. And so how we can perform demographic profiling and descriptive statistics, analyze descriptive statistics frequency, and for example, we want to see mean value. Write down here and then click OK. We have a new pane that is output pane. This table shows the frequency. The sample size is overall 7, missing value 0. So the frequency of the table shows that we are having 7, we get the data from 7 different individuals and Frequency of each individual is 1 over 7. This is percentage, that is 14.3 of each individual. This is valid percentage and this is cumulative percentage. 14.3 plus 14.3 is equal to 28.6 plus 14.3 is equal to 42.9, and similarly sum up to 100%. Back to main data view, we can similarly perform different demographic profiling like descriptive frequency, up to moment, look back, gender and age. Click OK. So this is the table shows that okay, we are having total number of samples 7, gender wise 7, age wise 7. There is nothing missing value in the data set. If we can see that the table for gender reflects that we are having male and female. So the frequency of male is 5 and the frequency of female is 2 over 7. The percentage for male is 71.4, whereas female participants are 28.6 over 100%. So 71.4 plus 28.6 is equal to 100% cumulative frequency percentage. Similarly, age-wise, we can see that the ages are reflected, the ages of respondents and left column, that is 33, 44, 37, 39, 42 and 45 according to the information that have been provided our respondent in the survey questionnaire. These are the frequency. The age of 34 has reflected 2 times. This is percentage and valid percentage, and this is cumulative percentage. 14.3 plus 28.6, 42.9 plus 14.3, 57.1, and similarly up to 100%. So this is how we can uh, estimate the demographic profiling of the respondent according to the different demographics. Like we can see that age-wise, gender-wise, and also we can see that ID-wise. So here we can also display these frequencies with the help of chart. For example, I use bar chart. So this is, it takes some processing time. So this is basically the bar chart for gender. The frequency of male is 5 and the frequency of female is 2. We can also use different type of chart in order to represent demographic profiling of our respondent. So this is age-wise demographic profiling. You can see that the frequency of 33 is up to near to 1, that is 14.3, and similarly the frequency of 34 age is equal to 28.6, and the rest of the frequencies are similar with respect to the first frequency. So this is how we can also perform demographic profiling and show the graphically as well. If we can see a complex data, for example, we are having these variables, that is sustainable project management having 14 items and stakeholder union having 8 items. Similarly, team building having 17 items and project success having 14 items. So first of all, similarly, we just define our variables and according to their types, according to their values. After that, just you can enter the data in the data view. So first of all, we just enter data. Here I am having 323 sample size. So how, first of all, we can see is there any missing value or not. For example, go to analyze descriptive statistics frequency and just selecting the one any one of the construct of any one variable. So just click on it. So what does the report show that? So this is the table. Yes, this is basically the frequency table. Overall sample size is 323, whereas missing value is 0. So we can say that we have entered the right data into the right column of sustainable project management 6 items. So it shows that the number of frequency of the value 1, 2, 3, 4, 5, 6, 7. This is basically the Likert scale which we have used in our research questionnaire. Likert scale like strongly agree, agree, disagree, neutral, strongly disagree, according to the researcher requirement. So the frequency of each, you can say that each value Likert scale is 1 is 12 to 16, 331, and similarly other values according to the overall 323 sample size. This is percentage, this is valid percentage, and this is cumulative percentage. Similarly, we have derived these percentage 3.7 plus 5.0 is equal to 8.7 plus 9.6 is equal to 18.3, and similarly up to 100%. This is how we can calculate the frequency and check the data. Is there any missing value in our data or not? Similarly, we can also perform this analysis for whole variable. For example, analyze descriptive statistics frequency, select the whole variable, and just selecting this is whole variable. Like just drag down and this variable drag back. Okay. So stakeholder engagement having 8 items, just click on OK. So how valid value is 323, that is sample size, and you do not have any missing value in any of the construct of stakeholder engagement as it shows 000. This is the individual item frequency table. Similarly, stakeholder 2, 3, 4, and up to 8. So we can also perform overall framework descriptive statistics. This is descriptive statistics frequency. Similarly, select back to all and then select all, click OK. So we can see that this is individual frequency table, but we can see overall cumulative frequency table as well. Is there any missing value on the data set or not? So this is, you can see that. So we are having total sample size is 323 without missing value is 0. You can see that overall we do not have any missing value in the data set. First of all, you can see whether our data set is completed or not. So have a look if we can. This is basically the data set. If I can delete the values from any of the items of the variable, how it can reflect. I'm just deleting it. So I just delete 3 variables from SPM1 and 1 data from SPSS. So now analyze descriptive statistics frequency, click on OK. So output screen shows that you can see these are individual tables, but we can see the cumulative frequency table. This is cumulative frequency table. So total sample size is 323 and missing value. So have a look. This sustainable project management one item shows that we have a missing value, 3 missing values. So the sample size will be 320, which is not correct because the sample size is 323. We need to add these values, missing values. Moreover, SPSS also have one of the missing values. So it shows 320, 322, the basically sample size which has been wrong. So we need to add these missing values. So this is how frequency table shows that either our data have missing value or not. So we will go back to our data and just write down these values and see the questionnaire so you can fill accordingly. Now dataset has been completed. This is how we can perform descriptive statistics and demographic analysis. Have a look. For descriptive statistics, analyze descriptive, select the variable. First of all, I'm just selecting any one items of any one variable. For example, project success time. Click OK, click on option. So as we discussed in theoretical part that descriptive statistics can be performed with the help of mean, standard deviation, variance, range, kurtosis and skewness. First of all, I'm just selecting mean. These values can be selected according to the requirement of the researcher. Mean, standard deviation, minimum, maximum, for example, range, kurtosis, skewness. Then just click on OK. So the output screen shows that this is basically the descriptive statistics. You can see that only one item, that is project success time. So overall sample size n is equal to 323, range is 6, minimum value 1, maximum value 7. These are basically the Likert scale. Strongly agree to strongly disagree. Mean, that is 4.6, standard deviation 1.6. It shows that if value of the mean above than 4, you can say that the data is highly acceptable. Similarly, this is standard deviation, this is skewness and kurtosis value. So the skewness and kurtosis values reflect that these statistics, you can use statistics. So this value represent that skewness acceptable limit is plus minus 1 and kurtosis is plus minus 2. So either these value within the limit of the threshold limit. Of course, this value is within the limit of threshold limit, that is plus minus 1, because it minus zero point 0.6, which is less than 1. So we can say that this is acceptable. And kurtosis value also minus zero point 0.5, which is the acceptable limit is plus minus 2, and minus 0.588 is less than plus minus 2. So this is how we can represent the descriptive statistics. But this is the analysis of only one item. So we can also go to analyze descriptive statistics, descriptive, select overall item of any one variable, like I can just select the variable of team building. 17 items. Click options, select your required analysis, click OK, and then. So this is basically the descriptive statistics table of an individual variable. You can see that the variable is team building (TB) and it contains 17 items according to your research questionnaire. Sample size in overall 17 items is 323, which shows that we do not have any missing values. This is minimum value 1 and this is maximum value 7. Minimum value and maximum value represents your Likert scale which have been utilized in research questionnaire. This is mean value, standard deviation value, Qness value and kurtosis value. This is how we can calculate descriptive statistics of our construct. We can also perform these analysis to our whole variable. For example, go to analyze descriptive, descriptive statistics, select all option, select the relevant statistics. These are already set. Just click on OK. So this is an overall descriptive statistics of our data. We can see that team building having 17 items, sustainable project having 14 items, stakeholder having 8 items, and project success also having 14 items. This is an overall descriptive statistics table. We just copy it into the Word file and we need to interpret accordingly. So copy, just click and copy and then paste it to your Word document. So this is how we can paste it in Word document. For example, just paste it. Yes, for example, this. Paste it in Word document. So how we can interpret descriptive statistics and demographic profiling for our article or our thesis. So have a look. First of all, demographic profiling. We can say that for our research, we can perform demographic profiling of our respondents with respect to gender-wise, age-wise, education-wise, sector-wise, for example. So how we can say that according to the gender-wise, here we are, say that we are having a total of 205 male and 118 female. So overall, the sample size will be 323. So the percentage of male female is 36 and male is 63%. So cumulative frequency will be 100%, that is 36.5% plus 63.5% is equal to 100%. This is how we can interpret our respondent demographic with respect to gender wise. Age wise, how we can interpret data. This is table shows that the overall demographic profiling with respect to gender age wise. Age from 20 to 29, 30 to 39, 40 to 49, and female 60 to 65. The frequency of data we have gathered data from the age between 20 to 29 or 157, 99, 42, 20, and 5, which is equivalent to 323, that is sample size. These are percentage, value percentage, and this is cumulative percentage, just we have calculated as earlier. Similarly, we can also perform education-wise. So this is basically the education-wise descriptive demographic profiling. Bachelors, we have collected data from different individuals, different project managers. So these project manager are team members having the education of bachelor degree is 21%, undergraduate are 226, graduate are 68, doctor are 8, which is it must be equivalent to your sample size, that is 323. These are percentage, value percentage, and cumulative percentage. So we can also perform demographic profiling with respect to sector wise. If we take we are having different type of sectors, we get the data from different sectors. Employee working in different sectors like construction, IT, and telecom. So the frequency of construction sector will be 121. These values are according to the questionnaire. 107 pertaining to IT sector and 95 pertaining to telecom, which have a total of 323. So this is how we can calculate demographic profiling, and we can interpret the value of demographic profiling in our dissertation or article. So how can we can interpret descriptive statistics? So as we discussed earlier, descriptive statistics can be performed with the help of means, skewness, kurtosis, standard deviation, range, variance, median, and more. So descriptive stat, how we can interpret the table of the descriptive statistics. For example, this is the table which we have copied from the analysis portion. This descriptive statistics pertaining to sustainable project management. How we can interpret this table? So first of all, descriptive statistics is an important tool used to summarize data meaningfully. Descriptive statistics are basically a summative approach used to represent the data cognitively. For the current study, a detailed descriptive statistics has been presented in the section. You can see that a detailed description of the descriptive statistics has been presented. So how we can interpret? If we just interpret it, we are having, so first of all, we are having overall 52 items and based on 323 sample size, that is survey questionnaire. All the items having different value ranging from 1 to 7 on 7 Likert scale. So the mean value sit from 4.393 to 5.396, whereas the standard deviation of all construct ranging from 1.704 to 1.523. So examining of normality testing in the data is an important check before applying different multivariate data analysis techniques. So that is structure function modeling and regression analysis. So in order to perform these analyses, we need to compute skewness and kurtosis. Kurtosis limit is plus minus 2, whereas skewness limit is plus minus 1. All the data has been shown that these values are within the acceptable limit of kurtosis plus minus 2 and skewness plus minus 1. Have a look, this is the table. We are having 14 items of sustainable project management. We are having the sample size is 323. The minimum value is 1 and the maximum value is 7, that is Likert scale value. You can see that this is the mean value which is ranging from 4.3 to 5.3. Minimum value and maximum value. Mean 4.3. So this is the minimum value of the mean and this is the maximum value of the mean. And data lies between minimum and maximum value. This is standard deviation also lies minimum value and between the maximum value. Skewness values, these are statistics and these are statistics for kurtosis, which shows that these value within the acceptable limit of skewness as well as kurtosis. So this is how we can interpret our table. So descriptive statistics can also be performed cumulatively as we see in the analysis portion and as well as individually. So this is a descriptive statistics of survey items of stakeholder engagement. So we can interpret the data. This table similarly we are having 8 items of stakeholder engagement with the sample size is 323 for each. One is minimum value, 7 is maximum value. These are the mean value of 8 construct of stakeholder engagement and these are standard deviation of 8 construct of stakeholder engagement. Skewness, these are skewness values and these are kurtosis values. So this is how we can interpret. Also, we are also having the descriptive statistics table of team building. It contains 17 items. Similarly, we can interpret the table accordingly and we are also having a table of descriptive statistics for our fourth variable, that is project success. So this is how in SPSS software we can perform the different type of analysis with respect to demographic profiling and descriptive statistics.